This is a Mark Leavenworth tall case woodworks movement made around 1815. The purpose of this video is to show the problems that the movement had and how the methods and how I made corrections and repairs to the movement. I'll demonstrate the striking. This is the back side of the movement. I have the movement on a temporary stand. The pendulum is a temporary pendulum used just to get the clock running. The original pendulum will be installed after the movement is put back in its original case. I'll demonstrate the striking as it's seen from the back side. The first thing that was wrong with this movement was that this pinion, which is on the escape wheel arbor, was broken, so I made a new pinion, turned the arbor down, and pressed on a new pinion and glued it in place. Then I had to true the outside diameter of the escape wheel to get it to work properly. It was a little bit, I had a couple of high teeth that had to be filed down. This is the governor or the fly. There was no tension on the arbor. The purpose of the fly or the governor is to absorb the shock when the striking sequence stops. So I put in a new piece of wood here and then put a little bit of epoxy and put more tension on the wire. We'll cycle this thing. The dowel on which the pendulum hangs was missing, so I made a new one with the approximate length. This is not glued in place. It'll have to be glued in place after the correct stick out from here to here is determined. So this is a new dowel to hold the pendulum. This is the gear on the original clock that drove the count wheel. As you can see, someone glued a broken tooth or leaf off of this pinion and glued it back on crooked. It also had a crack here. So my decision was to make a new pinion. This is the replacement pinion that drives the count wheel. I chose to put a brass pin to hold it on. There were a couple of damaged teeth on the count wheel, so you can see I glued a new tip on this one, and up at the top you can see I glued a new tooth on here. When I first assembled the clock, I discovered that the hole in this back plate and the hole in the seat board were off by a little more than 1/16 of an inch. So I made a new pin and drilled the hole deeper to secure this to that. Now this pin this dowel is not glued in. So after it's determined that it's running correctly, then the owner of the clock can glue this pin in place into the seat board. I installed bushings here, here, and here. I made new tapered pins out of maple to hold the clock together. One here and the two down at the bottom. That would be here and here. The great wheel on the strike side had many bad teeth, so after studying I decided to replace 12 teeth from here to here. I made a new gear, cut a segment out, and then glued the segment in, as you see here. You can probably see that dividing line. Then I had to replace 1, 2, 3, 4 pins, and it seems to be working properly. This is the new great wheel that I made to get new teeth, and this is the segment that I cut out of the old great wheel gear, and I had to replace 1, 2, 3, 4 pins. So that's how I made that repair. As a double check to make sure that the new teeth were proper diameter and spacing, I made a template of that gear to use to fit the new part in the old strike train great wheel. The holes that hold the bell, that is, these wires go down into a hole, they were both, the front and the back, were badly worn. So I drilled the holes out to 1/8, made little pieces of tubing 7/16 long, drilled these holes out to 1/8, and put the proper size hole, both front and back. The tips on the minute, arbor, and the hour pipe were both chipped on the corners, so I glued new pieces onto the corners, then drilled this hole, and I lined the hole with epoxy just to give it a little more strength. And the hour pipe square has 2 pins going on a 45-degree angle. I had to put new corners on the hour pipe and then drill for the very tiny pins to hold the hour hand on. One of the major problems with this clock was that this wire, it has a right angle bend. It works in initiating the strike cycle. That wire was missing, so I had to bend and experiment to get the right length, but it's now working properly. But we'll show you what happens with that wire. This clock on occasion would not stop the strike. This hammer, little hammer on a wire, goes down against a notch in the hoop wheel. That's H-O-O-P. That's a gear in the strike train, and it's used to stop the striking sequence. We'll show you how that works. You see at the end of the strike sequence, this hammer and the wire that goes into the count wheel both fall into place, and this actually locks the clock at the end of the strike cycle. Those edges, after 200 years, were worn, so I milled 30 thousandths off of the contact surfaces on those 2 gaps in the hoop wheel, coated it with epoxy, so I got a square corner and a new surface for the hammer to hit. After the movement is installed in its case, the proper length for the cord that holds the weight and the counterweight will have to be determined. I have a temporary stand here, so I could not get the proper length. To touch up scratches on the movement and any new parts or teeth in the gears, I use a felt tip pen like a magic marker. It's made by Miller, and it is called a Scratch Fix, dark brown. The number is SF1202.